The question is, a static electric charge distribution gives rise to an electric field on the form E equal to alpha into 1 minus e raised to minus r by r cap by r square, where alpha and r are positive constant. The charge contained within the sphere of radius capital R centered at the origin is. Here we have to find the amount of charge contained within a sphere of radius r. It is given that E, electric field E equal to alpha into 1 minus e raised to minus r by r cap by r square. It's a well-known equation that from Maxwell's first equation we know del dot E is equal to rho by epsilon 0. So, we know that E is a radial function. So, here we have to consider only the radial part of the del. So we can write by taking radial part of del and substituting in this equation we can write 1 by r square dou by dou r square into E equal to rho by epsilon 0. The next step we have to substitute the value of E. That is 1 by r square dou by dou r square into the value of E is given, that is equal to r square into alpha into 1 minus e raised to minus r by r into 1 by r square is equal to rho by epsilon 0. And here there is 1 r square and another 1 by r square, and these two terms get cancelled, and differentiating the remaining equation with respect to r we get, and taking alpha outside we get alpha by r square into minus e raised to minus r by r into minus 1 by r is equal to rho by epsilon 0, and from there we can find the value of rho. Rho is the charge density. That is rho is equal to alpha into epsilon 0 e raised to minus r by r divided by r square into r. We know charge density is the charge per unit volume, that is rho is equal to q by dV. From here we can find the value of the q. So q is equal to integral p dV. Here in the next step we have to apply the integration limit and substituting the value of rho and dV. We know q is equal to integral 0 to r, because we have to find the charge inside a sphere of radius r. So we have to integrate from 0 to radius of the sphere capital R, substituting the value of rho, that is alpha epsilon 0 e raised to minus r by r divided by r square r, and the volume of the sphere is 4 pi r square dr. And taking the common factors outside, that is 4 pi alpha epsilon 0 by r integral 0 to r e raised to minus r by r dr. And integrating this equation with respect to small r, we get 4 pi alpha epsilon 0 by r e raised to minus r by r divided by minus 1 by r in the limit 0 to r. And solving this we get that is equal to minus 4 pi alpha epsilon 0 into e raised to minus 1 minus e0, and interchanging these two terms we get q is equal to 4 pi alpha epsilon 0 into 1 minus 1 by. This is our answer.